Hey guys, today I'm going to talk with you about primary versus secondary joints when modeling a gantry. Last week I was in training at Energobit in Romania, so I did not have time to prepare for some of the older comments that I have from you. I'm going to do that in the next couple of weeks, I promise. So let's get into this gantry. I chose the dimensions in this figure: 15 meters height, 15 meters wide, 2.5 meters at the base, 1.5 meters here, and this is 3. So first, where do I put primary joints? Whenever you change the slope. In this case, we have a straight line. So when I design, I put primary joint here, 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 and here. And that's it, nothing else, nothing in between. This is not a primary joint, this is not a primary joint, and so on. So let's draw first the primary joints. This is number 1, 2, 3, and 4, because I need 4. We're going to do XY symmetry on all of them, because we all know that when you draw with XY symmetry, you get 4 points. When you draw with X or Y, you have 2 points. Let's see a little bit the coordinates. So I want to start with this one. First of all, this is the y-axis, as we know here. So this is the y-axis. So on y, we have 7.5, which is from the axis of your gantry to the axis of your column. So that's the main dimensions that you have to remember. Then you have, because we start to model at the bottom, we have 2.5. So that's 125 and 125, yes? So let's go here on y, we said first. You can do math here if you want. So that was 7.5 minus 125. And then another one equals 7.5 plus 125. Okay. Then on the x-axis, this is 2.5. And of course, this is like a square here. I don't have to tell you that. This is 2.5, this is also 2.5, right? So then, because we draw an axis, this is 125, okay? And this is also 125. Okay, now let's go to the ones at the top. At the top, what do you have? You have again 7.5, but this time you subtract or you add 0.75, yeah? So the half of this one. Then you go again, equals 7.5 minus 0.75 and equals 7.5 plus 0.75. Okay, and for this one, obviously you have 1.5 here, 1.5, so that's going to be 0.75. 0.75. Okay, and those are your joints. Let's press OK, and this is what we get. Yeah, wrong. Oh yeah, of course. Oh my god, I put them all on 0. So the height is 0, and for the ones above is 15. Yeah, okay, 0, 0, and this is 15. I'm not gonna edit this out because everyone makes mistakes. It's important to just realize in time. Okay, so that's your gantry. Now let's say, obviously, I have here an XY, and I'm going to draw them like this. Now, if you want to check your measurements, I'm just going to remove this one because we don't need it anymore. I'm going to check my measurements like this. This is 1.5, correct. 2.5. Obviously, if you want to see the middle, then you're going to have to draw some over Y symmetry here and here. We're going to draw one at the bottom also, just for measuring for the purpose of this video. 2 split in 2. Here the same, split in 2. And this one split in 2. And now we can find out if it's correct. 15, yeah? Okay, 15, perfect. Now, what I meant when I said that what I meant when I said that these are the only primary joints that I define is that I want all my joints, or most of them, to be collinear. So then, first of all, I would split this in two, so I can add the beam at the top. We said it's at height 12, yes. If we look here, this is 3, so 12. Obviously, you remove the fraction. 12. Let me copy this one and put it here as well. Paste 12, and then I can just draw over y. Yes, okay, this one. Okay, so this is how you draw a gantry, basically. Now, I want to show you something that applies for towers as well, and some people make a mistake, and I don't like that. And it's actually wrong, not just that I don't like it. Let's say I have obviously you have some crossing diagonals here. Let's say I have, I don't know, I'm going to split this again in two. And I have at, I don't know, 7.75 something as a height. Copy. I'm going to put this one here, paste. If you measure this now, you're going to see that this is 198. Now, why I don't recommend, so I would recommend putting as little as few. So I would recommend putting as few as possible primary joints to keep collinearity. Now, if, for example, you have here the crossing diagonals and they end here, and you want to make this a primary joint because the leg, let's say this would be one leg. Obviously, you cannot have one single profile on the entire length because it's 15 meters and we all know that's not happening. So let's say you have here a separate leg and you have a connection here. And you're going to say, oh, I can put here a primary joint because, you know, that's a connection. No, don't do that unless the slope changes. And the reason why I'm going to show you right now. The name of this joint is pretty ugly, so I'm just going to rename it to AS to show you something. Okay, let's say I make this a primary joint. Now, I think you know how you do that. You press F1, you convert secondary to primary, you have AS, and that's it. That's your primary joint. So let's say you added this at the beginning. Now, do you see how many decimals this has? A lot. So normally, if you would have added primary joints to begin with, and why that happens is because here we have 198. If you added this is 198 because you have 2 decimals. If you put 3 decimals, that's going to be more than that. So great, model check, that's not what I wanted. E, so if you put 4 decimals, it's even worse. So this is not a fixed number, yeah? So this proves it. You have a lot of this. These are the decimals that you would have to enter to have a straight line. But if you were to model this from the beginning with a primary joint, then you would have put probably here 1 instead of 0.99, and here maybe even 6.5, yes? So if you look at them now, nothing really changed because it didn't. But I want to show you something really nice. I'm going to make it with none just to show something. Look at the difference. Yeah, I'm going to make this one red just to show it. So this is the difference. Now, if you look at it from sort of far away, you're going to say, hey, that's fine. You know, it's a straight enough line, but it really isn't. The collinearity has been broken, and that's just it. So the basic knowledge that you have to get from this video is please don't add primary joints unless you really have a good dimension there, not an obtained dimension, right? So that's it. If the slope changes somewhere, this goes again for towers as well. If the slope changes, then by all means you have to add a primary joint. But if it doesn't, and the goal is to have a straight line, then making it secondary is the one and only way to achieve that, simply because of this. So I hope this makes sense. If it doesn't, please write me a comment. I can come back to you and explain some more. Thank you.